Okay, we are going to start with the word problems in the chapter LPP, linear programming problem. Now, to solve the word problems, we'll have to first get the inequalities. Okay, first get the inequalities. From inequalities, we'll be plotting the feasible region, and in that, we'll be then solving and finding out the unknowns. Right? The unknowns are called as decision making variables. A linear programming problem mainly is to either maximize profit in businesses or to minimize the cost of production. Minimizing the cost of production will automatically maximize the profit again. So, our aim in business should be maximizing the profit. It can be done in two ways, either to maximize the profit directly, or it can be the other means, the indirect means. By reducing the cost, you can again increase the profit. Okay, so the problems will be business problems, mainly commerce problems. Sometimes it comes in the biological science also, like to find out the minimum vitamins or minimum proteins, or what we need to get inside our body to keep us healthy and all. So it is about maximizing the profit most of the times, and it is used in some other areas also. Like the problem we have here right now is a business problem. If you read the problem carefully, it is a manufacturer producing bicycles and scooters. Okay, each is processed through machines A and B. Machine A has maximum of 120 hours and B has maximum of 180 hours. Manufacturing a bicycle requires 6 hours on A and 3 hours on B. Scooter requires 4 hours on A, 10 hours on B. Profit per bicycle is 10,000 and per scooter is 20,000. Maximize the profit. Okay, so first, whatever data is given to us, we should convert that into inequations. Okay, so for that, I'm going to create a table here, but before that, I'm going to identify my decision making variables. Decision making variables are the variables on which profit will depend. Profit depends on the selling of bicycles and scooters. Okay, profit depends on the selling of bicycles and scooters. So let number of bicycles sold or manufactured be X. Let the number of bicycles manufactured be X and scooters be Y. Let the number of bicycles manufactured be X and scooters be Y. Okay, so once you get that, then we can have a table from the data given to us. In table, in column, I am going to write bicycles X, scooters Y. Okay, bicycles X, scooters Why? The bicycles and scooters both are going to be processed through machines A and B. Okay, right? Now, the total availability is important. Okay, you can use the machine for certain number of hours. You can't keep using the machine for many hours, because that does not mean that the production, more the production, more the profit. It is not the only scenario. There has to be equivalent demand also, plus your machinery also can work up to certain number of hours. After that, it needs a break. Okay, in a week we can say, or in 2 weeks, whatever is the time period. So right now I am focusing on bicycles. We have X bicycles to be manufactured. Now bicycles go through machine A and machine B. So machine A, how much time bicycle needs on machine A? So manufacturing a bicycle requires 6 hours on A. Manufacturing a bicycle requires 6 hours on A. Bicycle requires 6 hours on A and 3 hours on B. So I can say 6 hours on A and 3 hours on B. Okay. Manufacturing a scooter requires, it's very easy. The word problems are very easy. 4 hours on A and 10 hours on B. So 4 hours on A, 10 hours on B. Total availability of machine A is for, machine A can be maximum used for 120 hours and B can be maximum used for 180 hours. So we have total availability of the machine for 120 hours, and for machine B it is 180 hours. Okay, so that is how I have created a table where I have written the products to be sold in columns, and the constraints, machine A constraint, machine B constraint, I have written in rows. Okay, so that it becomes a little easy for me to write down or identify the linear inequations. Okay, so after this, what we are going to do is, in this, I'll say bicycles need 6 hours on A and scooters need 4 hours on A. Okay, bicycles need 6 hours on A, scooters need 4 hours on A. Total time needed on A is 6x plus 4y hours. To manufacture X bicycles and Y scooters, total time needed on A is 6x plus 4y hours. but total availability is total availability is 120 hours. You can't use machine more than 120 hours. So that implies we have the first constraint. The first constraint is 6x plus 4y is less than or equal to 120. So that is the first constraint. The first constraint is 6x plus 4y is less than or equal to 120. That means the total time spent on machine A cannot exceed 120. It can be below 180, 120. Max to max, it can be 120, but it cannot exceed 120. You can use machine A for lesser number of time, or lesser number of hours, sorry. If there is lesser production, the time spent on machine A also will be less. It can be less than 120. It can be equal to 120, but you can't use machine A for more than 120 hours. That's the limit. Then you have to give break to machine A. Okay. Similarly, I'm not writing now the statements like this for machine B, but you will know that for machine B, there will also be a constraint. So similarly, you can say 3x plus 10y is less than or equal to 180. So bicycles need 6 hours on A, scooters need 4 hours on A. Total time spent on A is 6x plus 4y for X bicycles and Y scooters, but it can't cross 120. Similarly, bicycles need 3 hours on machine A, and bicycles need 3 hours on machine B, and scooters need 10 hours on machine B. Total time spent on machine B will be 3x plus 4y to produce X bicycles and Y scooters, and it cannot exceed 180. Okay? Yes. Now, after this is done, this is the question with us. Okay, so this is our question. So I have to say, since bicycles and scooters manufactured cannot be negative. Since bicycles and scooters manufactured cannot be negative, X, the number of bicycles, has to be greater than or equal to 0, and Y has to be greater than or equal to 0. So these are the constraints. These are the constraints called as non-negativity constraints. Okay, so we started with the decision making variables: bicycles and scooters, X bicycles, Y scooters. Machine A has maximum of 120 hours, B has maximum of 180 hours. Bicycle needs 6 hours on A, so X bicycles will need 6x hours. And Y scooters will need 4y hours. So 6x on A plus 4y on A cannot be 120. Okay, similarly, bicycles need 3 hours on B. One bicycle needs 3 hours on B. So 3x on B, and scooters के लिए it is 10y on B. 3x plus 10y cannot exceed 180. Okay, So those were the constraints we discussed here. Okay, this plus the non-negativity constraints are the inequations we have made out of the word problem. Okay, so I'll write the list here. The constraints are 6x plus 4y less than or equal to 120, 3x plus 10y is less than or equal to 180. Okay, then we have x greater than or equal to 0 and y greater than or equal to 0. These are non-negativity constraints. Okay, now one thing is remaining, the main objective of this problem that will give rise to also called as objective functions. So we have three important aspects in every problem of LPP. One is decision making variables, x and y. Then we have constraints, the linear inequations, which are the hindrances, which are the conditions in the problem. And the last thing is objective function. That is, the objective of this problem is to maximize the profit. Now, profit depends on obviously the number of bicycles and the number of scooters manufactured. In the question, it is said that there is going to be profit per bicycle is 10,000, profit per bicycle is 10,000, and per scooter is 20,000. So profit per bicycle is 10,000. So X bicycles will give you 10,000 X, and profit per scooter is 20,000. So Y bicycles will give you 20,000. Y scooters will give you 20,000 Y as profit. Okay, so total profit right is equal to 10,000 X plus 20,000 Y. And what are we going to do is we are going to maximize this profit. So what is the objective of this problem? The objective is maximize the objective function, that is z equal to 1000 x plus 20,000 y. What is the objective of the problem? The objective of the problem is to maximize the total profit. The total profit is 10,000 x plus 20,000 y, and the total profit can't be maximized just like that. It has to be under the restriction. So it is going to be subject to the constraints. Subject to, so it is subject to these constraints. Okay, the last one are x greater than or equal to 0, y greater than or equal to 0 are non-negativity constraints. So this is how in the previous lecture you had seen the inequations and what are the solution, what is the solution of inequation. It is a half plane. We have done all that, and now you are getting the source of those inequations, how those inequations arise from a word problem. You are getting to know that now in this lecture. Okay, so we are going to maximize z is 10,000 x plus 20,000 y, subject to the constraint 6x plus 4y less than or equal to 120, 3x plus 10y less than or equal to 180, x greater than or equal to 0, y greater than or equal to 0. Okay, so what happens is sometimes the question is asked only till here. This is a step where I would say if the question is formulate a LPP, formulate a linear programming problem. So this is it. This is a solution for that. Formulating a linear programming problem means you have to just create the question out of the word problem in the form of inequations and leave it. You don't solve the question. You just make the mathematical question out of the word problem and leave that question. So this is the question now in LPP. What is the question asking us to do? Maximize the profit. Subject to the constraints are given, that source is not given, where the constraints have come from is not mentioned. It is mentioned in the word problem. But you can be asked a question directly like this only. The question will start from here only. It can be an independent question. They don't want you to create the mathematical problem or the constraints. They'll straight away give you the constraints. They'll give you the objective function, and then you can start solving from there. So there are two types of question asked. One is to formulate the LPP. That is, you from the word problems you create the linear programming problem, the mathematical problem which is right in front of you right now. Second is they might give you the problem from here only. You start solving from here only and get the values of x and y which are suitable for us to maximize the profit. And the next can be, it can be the mix of the two. They might give you a word problem and directly ask you to find the values of x and y. So in that you have to cover both the types. That is, first you have to formulate the inequations, and the second step is to solve the inequations. It can be both asked in one question. Okay, so right now I am doing that. I'm creating the problem, the mathematical problem out of the word problem, and now I'm going further and I'm going to find the values of x and y. Okay, so I'm going to do two problems. I'm going to cover both the type of problems in one go. Okay, so formulation is done. If they ask you to formulate, you have to end your answer here. If they ask you to formulate and solve, you have to continue and solve this. They can also give you a question only to solve and not to formulate the inequations from the word problem. They might give you the problem from here only. Okay, so how